Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. So you can recall that in the last two lectures we had talked about the frequency distribution, and in the first lecture we talked about the frequency distribution for attributes and discrete data, and in the second lecture we talked about the frequency distribution for continuous data. So in the first case we had a command table which was used to get the frequency and the absolute frequencies actually, and in the second case when we handle the continuous data, then we had to do some more manipulations and we had to convert the numerical data using the cut commands into a factor, and then on that new transform data we had used the table command. Now in this lecture I am going to demonstrate that in R software there is a package fdth. Using this package you can obtain such frequency table directly also. So in this lecture we are going to talk about this fdth package, and I will demonstrate it by two examples. One, I will take the same example that we have considered in the earlier lecture, and one more example I will take from the mass data, that is our printer data set. So let us begin this lecture and try to understand how you can use the fdth package to construct such frequency distributions. So in R software there is a package whose name is fdth, right? And this package will help us in getting the frequency distribution. And as we know that the frequency distribution, they consist of absolute frequencies, relative frequencies and cumulative frequencies. Right. So as we have seen that when we try to create the frequency distribution for discrete and attribute data, that it was simple by using only the table command, but when we are trying to use for the continuous data, then we have to make some transformation, and we wanted to convert the continuous data into factor variables by creating certain intervals, and then we had used the table command. There is a package here fdth which can be used for creating the frequency distribution. So what you can do, you can install this package fdth by using the command install.packages, and then you can upload it. I already have done it on my computer already. So, and in the meantime I will try to explain you how you can use this fdth package. So one thing is very straightforward, that you can use the command here fdt, right? And then if you want to make it if you want to control different parameters, then I can explain you that there is a parameter here x which is trying to give here data vector, data frame or a matrix object, and the parameter here k which is trying to give the number of class intervals. And then we have to specify here start and end, which are the left endpoint of the first class interval and the right endpoint of the last class interval. And then we have to define here h, which is here the class interval width. After that we can define here breaks, right, and then say here na.rm. So this breaks is going to determine the number of class interval using one of the methods over here. Right will define the right endpoints have to be open or not. And similarly, as you have seen there that there is a command here for na.rm. If you try to recall, na.rm was the command to remove the missing value or not, which has to be given as true and false. So this is what you have to keep in mind. Right. In case if your data is in the form of a matrix, then you need to give only x, k and breaks over here along with right and na.rm. And if your data is in the framework of data.frame, then you also have to add one more option here, by, which is a categorical variable used for grouping each of the numeric variable. Right. So, and there are some more options, but I would request you to please look into the help menu to get more details. For us, this is more than enough. So now you can recall that earlier we had considered an example where 20 participants participated in a race, and their time for completion the race in second was given here like this. And based on that we had created this frequency table. But now I want to do the same thing using this fdth package, right? So now let me try to save this data in a time data vector. So I have taken here, I try to upload my package fdth, and now I use the command here fdt over time. Right, this is then it will take only the default value as I told you, and I try to save all these things in this variable ft. So ft will here look like this, you can see here. So you can see here, these are here the class limits, another column of frequency, relative frequency in percentage, cumulative frequency and cumulative frequency in percentage. But let me try to give you this in more detail and a clear format. So this is the screenshot what we had obtained. So you can see here that the first block is giving you here the class limits of the interval. So you can see here the intervals are like 31.68 to 40.54, 40.54 to 49.4 and so on, right. It has determined automatically by the default options. The second column here is frequency. So this is actually the absolute frequency. So there are 5 values in the interval 31.68 to 40.54 and so on. Then the next column here is relative frequency. So it is simply trying to take the total number of observation, that is absolute frequency 5 divided by 20, total number of observation, and it will give you the relative frequency of the first class, and similarly all other frequencies have been computed. Now the next column here is like this, RF, inside the parenthesis there is a percentage sign. So this is actually the relative frequency in terms of percentage. So 25%, 15%, 15% and so on. And after that the second last column here is cumulative frequency. So first cumulative frequency is 5, the second cumulative frequency is 8, then 11 and 14 and so on. You know that how to compute the cumulative frequencies, and then the same cumulative frequencies have been presented in terms of percentage. So you can see here that this is the frequency table which has been automatically created by default options using this fdth package using the command fdt. Now my objective is that I want to do it according to my wish, and I want to specify my own parameter as we have done it in the earlier case, right. So what I can do here that I can use here the same command fdt. I will here use the same data set time, but now I will start the sequence from 30. If you try to recall, in the case of continuous data, you had created the interval from in a sequence of 30 to 90 at an interval of 10. So the same thing I would try to do here. I will start the interval from 30 and end at 90, because the if you try to recall that we decided the range of the data, and then we decided that okay, all the values are lying between 30 and 90. So I can create the intervals at the breakpoints of 10. That means the class interval of width 10 units. So now this 10 width is given by this command here h, and right is equal to here false, and I try to save it as ft1. So you can see here now this data is exactly in the way which I wanted. My class intervals are 30 to 40, 40 to 50, 50 to 60 and so on. And then we have here these are here the frequency, then we have here the relative frequency, then relative frequency in terms of percentage, then cumulative frequency and cumulative frequency in terms of percentage. So the interpretation is the same, there is absolutely no issue, but I have now demonstrated that how you can control these parameters as per your requirement, and this is here the screenshot. So before I try to move further, let me try to show you these things in the R software also. So let me try to first copy this data set. So you can see here, this is here the data set here time, and now I will try to upload here the command this library. So I will use here the library fdth, and now I will use here the fdt over time. So you can see here that I need to save this data. So I will say here ft equal to 1, ft, and then I can see here this ft here is like exactly the same thing what you have obtained here, right. Now if you want to obtain this frequency table according to your wish, so where you are trying to define the start point, end point, the width yourself, then I use this command, and if you try to see here, this is here ft1. So this is now the same table which you have obtained here as per your requirement. right? And you can see that when you are trying to define your own specification, then the frequencies are changing. For example, here you can see that the frequencies are here something like 533342 in the first case here, and here the frequencies are 533522. So there will be some minor changes because of the change in the class interval or the width of the class interval. But it's okay, it's not a big difference. It is your choice what you exactly want to do, and my role is only to explain you that these are different possible ways. Now you have to work with these things. Now, just to give you more confidence, let me try to take the data set from the library mass about the painters and then try to do the same thing. So if you remember, we had a mass library, built-in library, in which there was one variable. It was composition in the data set painter. So painter's $composition will give me this data set that we already have used many times. So you know that this is the data set. Now I want to create the frequency table for this data set. So I will simply write down here fdt and painter's $composition, right? And I try to save it into ft paint comp, right? So these are the limits, and you can see here this is the same thing. Here these are the class intervals. Then the second column, it is here the frequency. Then the third column here is relative frequency. Then the fourth column here is relative frequency in terms of percentage. Then the second last column, this is here the cumulative frequency, and the last column here is the cumulative frequency in terms of percentage. So this is the same interpretation as you did earlier. So there is nothing new in this case. The only thing is you have to learn how to interpret it. And this is here the screenshot of the same operation, right? But in this case, if you try to see, I have used here the built-in default options. And now if I want to give my own specifications, then how to do it? So first I would try to find out the range of the data. So range of the data in the painter's $composition is 0 to 18. That means the minimum value is 0 and the maximum value is 18. Right. So let me try to have this frequency table for the intervals between 0 to 18, and so I try to give here the data. Then I say start equal to 0, end is equal to 18, and I try to create an interval of width 3, h is equal to 3. So you can see here now this data is here coming out to be like this. So that is the same interpretation. These are the class intervals, then frequency, then relative frequency in percentages, then cumulative frequency, and then cumulative frequency in percentage. Same interpretation, and this is here the screenshot, right? So you can see here it's not a very difficult thing actually. And if you also want to do it here, so let me try to show you these things on the R console. So first let me try to upload this library, so library mass, and then I try to use here this. It means I try to use the default option and try to create this frequency table. So you can see here, say this data is coming out to be like this. And now if I want to specify my own commands here, so I can say here like this, where the values are starting, the class intervals are starting from 0 to 18 at an interval of 3 units. So you can see here, this is the outcome, and which will be different from the first one. So you can see here now the class limits are 0 to 3, 3 to 6, 6 to 9, and the frequencies here are also changing. In this case, the frequencies are 1, 4, 3, 13, 6, 22, 5. And here in this case, the frequencies are changing 1, 4, 9, 9, 12, 17, right? So you can see here that it is not a very difficult job to create such a frequency table using this fdth package, but then you have to understand what exactly you are trying to do. And that was the objective when I explained you in detail in the case of continuous data by using the cut command, etc., that what exactly are we trying to do in order to achieve what we want. Now, if you don't understand those things, it will be very difficult for you to to work in this package where you have to define the starting value, end value, width, etc. And you will see in the help menu that there are many other options. So now the life becomes much simpler. Now I will stop here, but my job is to request you that please try to take some data set. Now even you can take big data sets without any problem. Try to use this fdth package. Try to give different start value, end value, class width, etc., etc. Try to use different types of options given over there, and try to see which of the option is giving you the most suitable reply which you wanted, which you feel that it is close to the real world or in reality whatsoever is happening. So you try to practice it, and I will see you in the next lecture with some more topics. Till then, goodbye.